Okay, enough with the core losses, now something else and some useful formulas now. Now, I'm going to show you the sinusoidal excitation in magnetic circuits and therefore in AC machines. So, flux and induced EMF in this coil and in this the flux in these magnetic circuits are with the sinusoidal nature. So we usually bring sinusoidal waves on this magnetic circuit usually, especially with transformers, AC machines, and I'm gonna show you some formula. So the flux in this magnetic circuit changes with this law or formula. So the amplitude, which is equal to F flux maximum times the sinus omega t. So this is the angle, and omega here is the angular velocity, which is equal to 2 pi times the frequency of the flux variating in the magnetic circuit. So here you have a flux, and because it is a sinusoid, it goes from 0, and it's not a perfect perfect picture, but you get it, I hope. Now, the induced EMF by Faraday's law is number of turns, or the flux linkage, the change dF by dt. So now we have the derivative of this flux by dt is equal to, because this is a constant, it stays, we just have to derive sinus omega t by dt. Now, and that is equal to omega cosine omega t. So, t. So, if you don't know mathematics, derivatives, differential equations, I advise you to work that out a little bit. Now, here we have number of turns plus flux maximum plus omega, angular velocity, is equal to the induced voltage maximum. So here this is this, and we just copy cosine omega t. So now, as you can see, if we have a magnetic circuit here, and if we have cosine omega t, or a flux in sinus omega t, here is the graphical representation how it changes through time. Now, the induced EMF acts by the cosine omega t, and the flux by time is changing by this formula. So this is the amplitude flux maximum, and this is the amplitude E maximum. Now, as you can see, the induced EMF is leading by 90 degrees in front of this flux. Now, as you can see, we have E that is up, and perpendicular here you have flux. So the flux is lagging behind the induced EMF in magnetic circuits with sinusoidal excitation. Now, I think you get it, the point with this induced EMF and flux, and this is very important to know. Now, how do we measure the RMS, the root mean square of this induced on this coil? How do we measure the RMS? Well, by formula, the RMS, in my language, this root mean square is called effective voltage, but in English literature it is called root mean square. So we measure it by dividing the amplitude of the voltage with the square root of 2. Now, that is equal here, E max, the maximum voltage induced in this coil, is equal to number of turns times the maximum flux times the angular velocity. And we write that down. The angular velocity is equal to 2 pi times the frequency. Now, instead of this omega, we write 2p f flux max n divided by square root of 2. And now 2p divided by square root of 2, you can measure this on your calculator, is equal to 4,44. Now here this is this. So this is the value when you first multiply 2 with pi and divide it by square root of 2. And then you get the RMS of the induced voltage in this coil is equal to 4,44 number of turns n times the frequency times the maximum flux in this magnetic circuit. And this is a very important formula. You should write this down, that E is equal 4.44 n frequency flux. So this is a very important formula with AC machines. Also with transformer, which is also an AC machine. It's not a motor, it's not a generator, but it's an AC machine. And that's another chapter. So this is a very important formula, and in my next tutorial I'm going to do example with these formulas. So write all these down and see you in my next video. Goodbye.